Alright, welcome to Rational Functions Level 2. Now in our first example, we have this rational equation that we want to solve. And what I want to see here is I see that this denominator is x plus 3. And when I look here, I suspect x plus 3 is probably one of its factors. So here's what we'll write. We'll write 1 over x plus 3 plus, and here, when I write this one, what I'll do instead is I'm actually going to split it up into its two factors. So a great trick here is whenever you see some sort of complex denominator, always try to factor it. I seem to be having some stylus issues as well, so I need to write just a little bit slower here for it to pick up. My apologies. So when we're starting to factor this, I want you to think, what two numbers add up to be 8 and multiply to be 15? Well, we know that both of our factors here are going to start with x because x times x is what gives us x squared ultimately, plus, and when you think about it, what two numbers add up to be 8 and multiply to be 15? Well, what about 3 and 5? Let's see, 3 plus 5 is 8, and 3 times 5 is 15. Okay, so that works out. And now, all we have to do to begin solving this problem is we have to multiply this one rational expression right here by the one factor it's missing. So since it already has an x plus 3, we simply have to multiply by an x plus 5. Now, remember what we do to the bottom, we also have to do to the top. And so here I have x plus 5 as well. Okay. Now the cool thing here is this 1, it will distribute, but multiplying by 1 really doesn't change things. So this gives us, on the very top, x plus 5 plus, and we see here this right there, 5 is equal to 8. Now I want to kind of talk about what I just did there. So after distributing this 1 times the x plus 5, we have our x plus 5 there. What we can actually do with a rational equation is whenever our denominators are all the same, so this is the same as that, is the same as that, we can actually ignore the denominator just for the moment, okay? And so when I ignore the denominator, because now I have common denominators, I can add these things on top. I simply write x plus 5 equals 8. Now, what happens when we combine our like terms? Well, 5 plus 5 will give us 10. So we have x plus 10 is equal to 8. And this becomes an incredibly simple problem. Now, how can you get rid of plus 10? Well, minus 10, and it turns out x is going to equal negative 2. Now there's one final thing you have to check because this is where the denominators are truly meaningful. If we were to plug x equals negative 2 in for this x or for this x, would it give us 0? And if it would, then it's not a solution. So I'll just kind of draw this box right here. We'll take the factor x plus 3. So if I plug in negative 2 plus 3 is equal to 1. Well, as long as it gives us any number other than 0, it's a solution. Okay, so that's definitely a solution in regards to this factor. Now let's test it out with this other factor. If I were to test out x plus 5, I were to do negative 2 plus 5, well, we should see, obviously, it will give us 3, which is not 0. So this, negative 2, is in fact our solution. Pause this video, finish taking any notes that you need to, and let's move on. Okay, let's take a look at example 2. Now in this one, it's going to be a very similar problem as example 1, and we want to solve this rational equation for x. So notice this very first denominator is x minus 4. And in fact, I want to give you kind of a cool little strategy here. When you're given one of these problems, I would like for you to kind of use the assumption, oh, you know what, I bet x minus 4 is going to be a factor there, and I bet it will be a factor there. Because if it's not, that would make this a problem so difficult it would be beyond the scope of this class. So let's go ahead and break down this factor right here. Okay, we're going to break down that middle factor, but let me finish writing out this. Now I want to make one other note. Notice how I'm breaking down this factor, but I'm leaving this factor the same. And the reason I'm going to do that is because I want you to truly understand that even when this is factored, it still has an equivalent value of its unfactored form. Okay, so that's just something that's very important to keep in mind. Now when you look at this, we want to know what two things add up to be positive 6, but multiply to be negative 40. And a good way to do something like this, where it's a little bit trickier, is simply write negative 40 and just list out all the factors you can think of. So off the top of my head, I think, oh, you know what, maybe it's negative 2, and maybe it's 20. But I see here we have this negative 4, so what if I chose negative 4? Well, negative 4 times what number gives me negative 40? Well, that would be negative 4 times 10. And what is negative 4 plus 10? Well, that actually gives me positive 6. So it turns out that x minus 4 and x plus 10 are going to be our factors. Once again, I do apologize for these stylus problems. Okay, now when I look at this left little factor, or this left fraction, I notice it has the x minus 4, but what it's missing is this x plus 10. So in order for us to get to a common denominator, I have to multiply this by x plus 10. And remember, whatever I do to the bottom, I can now do to the top. So we'll multiply the top by x plus 10. And our last little thing that we need to remember is that whenever we have common denominators, x plus 10, x minus 4, x plus 10, x minus 4, and x plus 10, x minus 4, at this point, we can essentially ignore the denominators until the very end. So I know this 9 distributes. We get this. We get 9x. And we know 9 times 10 would, of course, give us 90. And now that we have this, and it has a common denominator with this, we can, of course, add it with the 6. And here, we can now set this equal to 14. Okay, so what happens when you solve this? Well, we know that 90 plus 6 will of course give us 96. So I have 9x plus 96, and this will equal 14. And now we have a basic Algebra 1 equation to solve. What should we get rid of first? Our coefficient in front of x, or the addition or subtraction? And if you watched any of my videos, you know that we should get rid of the addition first by subtracting its inverse operation. And so let's subtract both sides by 96. Now that goes away. And I'm going to bring this kind of up here where I have a little bit of space, way up top. We now have 9x is equal to 14 minus 96 will actually give us negative 82. And how can we get rid of the 9? Well, we divide both sides by 9. And when we do that, we're going to get this. X equals, and you know what, for this, because it's not going to give us a perfect number, I would encourage you to go grab your calculator. So let's see, grabbing my calculator, 82 divided by 9 will be negative 9.11. And I always like to round to the nearest hundred. Now the last thing you would do is you would plug that into these bottom two factors. However, negative 9.11 minus 4 is definitely not 0. And negative 9.11 plus 10 is also definitely not 0. So this will in fact be our correct solution. Alright? Well, I hope this helps, and I'll see y'all in our level 3 video.